What if I told you that the future of space exploration might not involve rockets at all? Instead, picture a structure so tall it reaches into orbit, a towering tether connecting Earth to the stars, a space elevator. This isn't just a far-off dream from a sci-fi novel. It's a real concept being explored by scientists and engineers today, and it could completely transform how we think about space travel. Imagine a world where reaching space is as routine as taking a train or flying in a plane. No more billion-dollar launches, no more dangerous rocket explosions, just a smooth, steady ascent into the cosmos. In this video, we're going to break down how space elevators could make space exploration faster, cheaper, and more sustainable than ever before. We'll explore the science behind them, the challenges we'll need to overcome, and how they could open up the stars to everyone, not just astronauts and billionaires. So, buckle up. By the end of this, you might just see the future of space travel in a whole new light. Imagine a world where launching into space is as simple as stepping into an elevator and pressing a button. No roaring rockets, no explosive liftoffs, just a smooth, steady climb into orbit. That's the promise of space elevators, a concept that might sound like science fiction, but is rooted in real, groundbreaking science. At its heart, a space elevator is a towering structure that stretches from the Earth's surface all the way into space, tens of thousands of kilometers high. Picture it like a cosmic bridge, anchored firmly to the ground and balanced by a massive counterweight in geostationary orbit. This counterweight, often imagined as a space station or even an asteroid, keeps the entire system stable, acting like the keystone of an arch. The real magic happens along the tether, a super strong ribbon or cable that connects the Earth to the counterweight. Climbing this tether are specialized elevator cars, or climbers, designed to carry payloads, satellites, or even people. These climbers wouldn't rely on traditional rocket propulsion. Instead, they'd use advanced technologies like electromagnetic drives or laser-powered systems to ascend steadily, eliminating the need for explosive fuel and drastically reducing costs. The idea of a space elevator isn't new. It was first proposed back in 1895 by Russian scientists, inspired by the tower. But what was once a dream is now closer to reality, thanks to advancements in materials science and engineering. Modern concepts focus on materials like carbon nanotubes or graphene, which are incredibly strong yet lightweight, essential qualities for building a tether capable of withstanding the immense forces it would face. So how does it all work? Think of it as a giant balancing act. The tether is anchored at the equator, where the Earth's rotation provides the necessary centrifugal force to keep the system stable. As the climber ascends, it gains altitude and speed, eventually reaching orbital velocity by the time it reaches the counterweight. This elegant design not only makes space travel more efficient, but also opens the door to a future where accessing orbit is as routine as catching a train. But building something this ambitious isn't without challenges. From developing materials strong enough to handle the stresses of space to ensuring the tether can withstand space debris and weather conditions, there's a lot to consider. Still, the potential rewards are immense, offering a sustainable and cost-effective way to revolutionize space exploration. Now, let's talk about the backbone of any space elevator, the tether. This isn't just any ordinary rope or cable. It has to be the strongest material ever created, capable of enduring forces that would snap steel like a twig. The key to this lies in one of the most revolutionary materials of our time, carbon nanotubes. These tiny, cylindrical structures made entirely of carbon atoms are a marvel of modern science. Imagine a material so strong that it's up to 100 times stronger than steel, yet incredibly lightweight. That's the power of carbon nanotubes. Their strength-to-weight ratio is unmatched, making them the ideal candidate for the tether of a space elevator. Without them, the entire concept would remain a pipe dream. But why are carbon nanotubes so special? At the atomic level, their structure is like a tightly woven lattice, giving them extraordinary tensile strength. This means they can withstand incredible pulling forces without breaking, which is exactly what a space elevator tether would need to do. Picture this. The tether would stretch from Earth's surface all the way into space, over 22,000 miles long. Along its length, it would face constant tension from Earth's gravity, as well as the centrifugal forces caused by our planet's rotation. Ordinary materials would buckle under such strain, but carbon nanotubes have the potential to hold firm. However, there's a catch. While carbon nanotubes are incredibly strong in theory, producing them on the massive scale needed for a space elevator is a monumental challenge. Right now, scientists can only create them in small quantities, often just a few centimeters long. Scaling up production to create thousands of miles of nanotube-based cable is a problem that hasn't been solved yet. And even if we could produce enough, ensuring the material maintains its strength over such vast distances adds another layer of complexity. It's not just about making the nanotubes, it's about weaving them into a cohesive, flawless structure that can handle the rigors of space travel. Despite these challenges, the potential of carbon nanotubes is too significant to ignore. They represent the first real possibility of building a tether that could make space elevators feasible. Without them, the dream of a cost-effective, reusable pathway to space remains out of reach. So, while the road to creating a space elevator is still filled with obstacles, carbon nanotubes are the beacon of hope guiding us forward. They're not just a material, they're the foundation of a future where reaching space could be as routine as taking an elevator to the top floor. When we think about the cost of space travel today, the numbers can feel almost otherworldly. Sending just 1 kilogram of payload into orbit can cost anywhere from $10,000 to tens of thousands of dollars, depending on the mission. For a single rocket launch, that adds up to millions, if not billions, of dollars. It's no wonder that space exploration has largely been the domain of governments and a handful of well-funded private companies. But what if there was a way to slash those costs by a staggering margin? That's where space elevators come in. Unlike traditional rockets, which burn enormous amounts of fuel to escape Earth's gravity, a space elevator would rely on a tether anchored to the planet's surface, extending tens of thousands of kilometers into space. The climbers, essentially vehicles that travel up and down the tether, would be powered by electricity, making the entire process far more efficient. Once the initial infrastructure is in place, the ongoing costs would be minimal, primarily tied to maintenance and energy consumption. This shift could reduce the cost of sending payloads into orbit to just a fraction of what we pay today, potentially as low as a few $100s per kilogram. The economic ripple effects of this reduction would be monumental. Private companies, currently priced out of the space industry, could suddenly afford to launch satellites, conduct research, or even establish manufacturing facilities in orbit. Universities and research institutions, which often operate on tight budgets, could send experiments into space without breaking the bank. And let's not forget the potential for space tourism. With costs dramatically lowered, the idea of an average person taking a trip to space might not sound so far-fetched after all. But the benefits don't stop there. A space elevator could also serve as a gateway for larger-scale projects, like asteroid mining or the construction of space habitats. These ventures, which seem like science fiction today, could become economically viable with the kind of cost savings a space elevator offers. The ability to transport materials and people into orbit could a new era of innovation, transforming space from a distant frontier into a thriving hub of activity. Of course, building a space elevator is no small feat. The engineering challenges are immense, and the upfront costs would be substantial. But when you consider the long-term savings and the potential to revolutionize space travel, the investment starts to look like a bargain. It's a classic case of spending a little now to save a lot later, and to unlock possibilities that could change the course of human history. So, what does this mean for the future of space exploration? If we can overcome the technical hurdles, space elevators could fundamentally alter the economics of getting off Earth. They could make space accessible to a far wider range of people and organizations, fostering innovation and discovery on an unprecedented scale. And that's not just about saving money, it's about opening up the cosmos to everyone. When we think about the environmental cost of space exploration, traditional rockets often come to mind. Massive machines burning through tons of fuel, leaving behind trails of greenhouse gases and debris. But what if there was a cleaner way to reach the stars? Enter space elevators, a concept that could revolutionize not just how we explore space, but how we protect our planet while doing so. Unlike rockets, which rely on combustion and release harmful emissions directly into the atmosphere, space elevators would operate on clean energy sources like solar power, producing no direct emissions during operation. This alone makes them a tantalizing alternative for a future where sustainability is paramount. But the benefits don't stop there. Rockets aren't just polluting during launch. They also leave behind a growing problem of space debris, which poses risks to satellites, spacecraft, and even future missions. Space elevators, on the other hand, could provide a controlled, debris-free pathway to orbit. Imagine a system where payloads are gently lifted into space, rather than violently blasted through the atmosphere. This could drastically reduce the amount of debris cluttering Earth's orbit, making space safer and more accessible for everyone. Of course, no solution is without its challenges. While space elevators promise a cleaner operation, their construction could come with its own environmental costs. Mining the materials needed for the tether, likely a mix of ultra-strong carbon nanotubes or other advanced composites, could have significant ecological impacts. The manufacturing process itself would require energy and resources, potentially offsetting some of the environmental benefits. And let's not forget the logistical challenges of building such a massive structure, which could disrupt ecosystems or require land use in ways we haven't fully considered yet. So, are space elevators truly greener than rockets? The answer isn't black and white. While they offer a cleaner, more sustainable way to access space once operational, their construction and material needs present a complex set of environmental trade-offs. What's clear, though, is that they represent a step toward rethinking how we approach space exploration, not just for the sake of science, but for the health of our planet. The question now is whether we can balance the promise of this technology with the responsibility to protect the environment every step of the way. Picture this: a thread stretching from Earth's surface into the vastness of space, held taut by forces that seem almost magical. But the magic here is pure physics, and it all hinges on one critical concept: geostationary orbit. This is the sweet spot, the perfect altitude where Earth's gravity and the outward pull of centrifugal force cancel each other out. At roughly 35,786 kilometers above the equator, objects in this orbit move at the same speed as Earth's rotation, effectively staying fixed over a single point on the planet. For a space elevator, this is the anchor point, the place where the tether can remain stable, neither falling back to Earth nor drifting off into space. But why is this balance so crucial? Let's break it down. Earth's gravity pulls everything toward its center, while the centrifugal force created by the rotation of the planet pushes outward. In geostationary orbit, these two forces are perfectly matched. This means the tether of a space elevator can stay in place, creating a stable pathway for climbers to ascend and descend. Without this precise balance, the entire system would collapse, either dragged down by gravity or flung into space by centrifugal force. The engineering challenges here are immense. The tether itself must be incredibly strong yet lightweight, capable of withstanding the stresses of its own weight, the weight of climbers, and the forces exerted by Earth's rotation. And the counterweight at the top, it's not just a passive anchor, it's an active participant in maintaining this delicate equilibrium. Scientists have proposed everything from massive asteroids to specially designed structures as counterweights, each solution bringing its own set of complexities. Understanding orbital mechanics is key to making this work. Geostationary orbit isn't just a random height, it's a calculated position where the math of gravity and motion aligns perfectly. For space elevators, this isn't optional, it's the foundation of the entire concept. Without geostationary orbit, the dream of a space elevator would remain just that, a dream. But with it, we unlock a new era of space exploration, one where reaching orbit is as routine as taking an elevator to the top of a skyscraper. So what does this mean for the future? It's a reminder that the most groundbreaking innovations often rest on the simplest principles of science, principles like balance, motion, and the forces that shape our universe. And as we continue to explore these ideas, we edge closer to making the impossible possible. The counterweight at the top of the space elevator isn't just a heavy object, it's the anchor that holds the entire system together. Picture this, a massive structure, positioned tens of thousands of kilometers above Earth, pulling the tether taut like a cosmic balancing act. Without it, the tether would slacken and the entire system would collapse. This counterweight acts as a stabilizer, ensuring the tether remains under tension, even as climbers, the vehicles designed to carry payloads, ascend and descend along its length. It's a delicate dance between mass and motion, where every detail matters. Now let's talk about the climbers. These aren't your typical vehicles. They're designed to move along the tether, transporting everything from satellites to cargo and even humans into space. But moving along such an immense structure isn't as simple as driving up a hill. Friction, energy consumption, and the sheer distance pose significant challenges. To overcome these hurdles, engineers are exploring cutting-edge propulsion systems. One promising solution: laser-powered climbers. By beaming energy from the ground to the climber, these systems could eliminate the need for heavy fuel, making the journey faster and far more efficient. What makes this even more fascinating is the interplay between the climbers and the tether itself. As a climber ascends, its weight shifts the balance of the system, requiring constant adjustments to maintain stability. It's a dynamic process, demanding precision engineering and real-time calculations. And while the concept may sound like science fiction, the principles behind it are grounded in physics and innovation. From advanced materials to energy-efficient propulsion, the mechanics of space elevator movement are a testament to human ingenuity and a glimpse into the future of space exploration. So, how do space elevators compare to the rockets we've been using for decades? Let's break it down. Rockets have been the backbone of space exploration, delivering speed and flexibility. They can launch almost anywhere, reach orbit in minutes, and adapt to a variety of missions. But this convenience comes at a steep price, literally. Launching a single rocket can cost hundreds of millions of dollars, and much of that expense comes from the fact that rockets are essentially single-use vehicles. Once they've delivered their payload, most of the rocket either burns up in the atmosphere or becomes space debris. That's not exactly sustainable, is it? Now let's look at space elevators. Picture a giant tether stretching from Earth's surface into space, with climbers slowly but steadily moving payloads up and down. It's not as flashy as a rocket launch, but here, where it shines, sustainability. Unlike rockets, space elevators are designed for repeated use. You could send payloads up and down the tether countless times without the need for constant refueling or rebuilding. And because they're powered by electricity, potentially from renewable sources, their environmental footprint is minimal compared to the massive carbon emissions and chemical pollution produced by rocket launches. But what about cost? Rockets are expensive not just because of their single-use nature, but also because of the sheer amount of energy required to break free of Earth's gravity. Space elevators, on the other hand, could drastically reduce those costs. Once the infrastructure is in place, the cost per kilogram of payload could drop to a fraction of what rockets charge. Imagine sending supplies, satellites, or even people into space for a fraction of the price. That's the kind of affordability that could open up space exploration to more nations, companies, and even individuals. Then there's payload capacity. Rockets are limited by their size and the amount of fuel they can carry. A space elevator, however, could theoretically transport much larger payloads. Think massive components for space stations or even habitats for future colonies. And since the climbers move at a steady, controlled pace, delicate equipment or sensitive experiments could be transported without the intense vibrations and G-forces of a rocket launch. Of course, space elevators aren't perfect. They're slower, taking days or even weeks to reach orbit compared to a rocket's minutes. And building one would be a monumental engineering challenge, requiring materials we're still developing and a level of global cooperation we've rarely seen. But when you weigh the long-term benefits, lower costs, reduced environmental impact, and the ability to transport larger payloads, it's clear why space elevators could revolutionize how we explore the cosmos. So, while rockets will always have their place in missions that demand speed and precision, space elevators offer a vision of the future where space travel becomes more accessible, sustainable, and routine. It's not about replacing rockets, it's about complementing them, creating a system where both technologies work together to push humanity further into the stars. Building a space elevator isn't just about engineering or materials, it's about people. It's about nations, industries, and scientists coming together to achieve something that no single entity could accomplish on its own. Think about it. The International Space Station is a shining example of what's possible when countries unite for a common goal. But a space elevator, that's on an entirely different scale. It's not just a laboratory in orbit. It's a permanent, game-changing infrastructure that could redefine how we access space. And to make it happen, we'd need a level of global cooperation that's never been seen before. The challenges are immense. First, there's the technology. No single country has all the answers when it comes to materials science, robotics, or orbital mechanics. The carbon nanotubes needed for the tether, the autonomous climbers to transport payloads, the geostationary platforms. These are all pieces of a puzzle that would require expertise from around the world. Imagine researchers in Japan perfecting the nanomaterials, engineers in the United States designing the climbers, and European companies developing the power systems. Each nation brings something unique to the table, and together they could create something extraordinary. Then there's the funding. A project of this magnitude would cost hundreds of billions of dollars, if not more. No single government or corporation could shoulder that burden alone. It would take a coalition of nations, private investors, and international organizations pooling resources to make it feasible. Think of it like crowdfunding on a planetary scale. Everyone who contributes gets a stake in the future of space exploration. A future where launching satellites, building habitats, or even mining asteroids becomes as routine as taking a flight across the globe. But perhaps the biggest hurdle isn't technical or financial, it's political. A space elevator would span international airspace and orbit, raising questions about sovereignty, security, and governance. Who gets to control it? How do we ensure it's used for peaceful purposes? These are questions that would require diplomacy on an unprecedented level. Treaties would need to be drafted, agreements signed, and trust built between nations that may not always see eye to eye. But if we can pull it off, it could set a new standard for international collaboration, proving that humanity is capable of working together to achieve the extraordinary. And let's not forget the private sector. Companies like SpaceX, Blue Origin, and others are already pushing the boundaries of space travel. Their involvement would be crucial, not just for funding, but for innovation. Imagine a future where governments and corporations work hand in hand, sharing risks and rewards to build something that benefits us all. It's not just about profits or prestige, it's about creating a legacy that transcends borders. So what would it take to make this kind of global partnership a reality? It starts with a shared vision. A space elevator isn't just a feat of engineering, it's a symbol of what we can achieve when we unite for a common purpose. It's a reminder that the challenges we face, whether in space or here on Earth, are too big for any one nation to tackle alone. But together we can reach new heights, quite literally. And in doing so, we might just discover that the real power of a space elevator isn't just in the technology, it's in the unity it inspires. What if your next vacation wasn't to a beach or a mountain, but to the stars themselves? Space elevators could make that dream not just possible, but surprisingly accessible. Picture this: stepping into a sleek, futuristic cabin, strapping in, and watching as Earth's surface slowly shrinks beneath you. Within hours, you're floating in orbit, gazing at the curvature of our planet from a space hotel. No rockets, no intense G-forces, just a smooth, elevator-like ride to the cosmos. This isn't science fiction anymore. It's a vision of what space tourism could become with the help of space elevators. Right now, companies like SpaceX and Blue Origin are making strides in commercial, but their rocket-based systems are still expensive and limited to a select few. Space elevators, on the other hand, could democratize access to space. By using a tether anchored to Earth and extending tens of thousands of kilometers into space, these elevators could carry passengers and cargo at a fraction of the cost of traditional rockets. Think of it as the difference between taking a private jet and hopping on a high-speed train. Suddenly, space isn't just for astronauts or billionaires, it's for everyone. And the possibilities don't stop at tourism. Space elevators could open the door to orbital hotels, lunar resorts, and even interplanetary travel hubs. Imagine a world where a weekend getaway to a space station becomes as routine as a trip to Paris. Families could celebrate milestones by watching Earthrise together, while researchers and artists could find new inspiration in the vastness of space. The ripple effects could be profound, sparking a new era of exploration and connection that brings humanity closer to the stars. Of course, making this vision a reality will require overcoming significant challenges, engineering hurdles, international cooperation, and massive investments. But the potential rewards are staggering. Space elevators could transform not just how we travel, but how we see ourselves in the universe. They could turn the cosmos from a distant frontier into a familiar destination, inviting us to explore, dream, and connect in ways we've only just begun to imagine. Imagine a world where studying the cosmos doesn't require launching a rocket every time, where scientists can send delicate instruments into orbit without the intense vibrations and costs of traditional launches. This is the kind of accessibility that space elevators could bring to scientific research, opening doors to experiments and observations that were once out of reach. By providing a steady, reliable pathway to space, space elevators could revolutionize how we explore the universe and understand our own planet. Take microgravity research, for example. Currently, experiments in microgravity are limited to brief moments during rocket launches or aboard the International Space Station. But with a space elevator, researchers could transport experiments to orbital platforms with ease, allowing for longer, more controlled studies. This could lead to breakthroughs in materials science, biology, and even medicine. Think of growing crystals for advanced electronics or studying how cells behave in zero gravity to develop new treatments for diseases. And it's not just about what happens in space. Space elevators could also transform how we observe Earth. Imagine deploying advanced climate monitoring satellites at a fraction of the current cost. These satellites could provide real-time data on weather patterns, deforestation, and even the health of our oceans, giving scientists the tools they need to tackle climate change more effectively. But the impact doesn't stop there. Space elevators could also make astronomy more accessible. Instead of relying on ground-based telescopes, which are limited by Earth's atmosphere, astronomers could deploy larger, more sensitive instruments directly into orbit. This could lead to discoveries about distant galaxies, exoplanets, and even the origins of the universe itself. What makes this even more exciting is the potential for collaboration. With easier access to space, universities, research institutions, and even smaller nations could participate in cutting-edge experiments, democratizing space exploration in ways we've never seen before. The ripple effects of this accessibility could lead to an explosion of innovation, with discoveries that benefit not just space exploration, but life on Earth as well. From unlocking the secrets of the cosmos to protecting our planet's future, the scientific potential of space elevators is nothing short of transformative. And as we look ahead, it's clear that this technology could be the key to unlocking a new era of discovery, one where the mysteries of the universe are within our grasp like never before. One of the most transformative possibilities tied to space elevators lies in their ability to unlock the untapped wealth of our solar system: asteroid mining. Picture this: floating out in the asteroid belt are countless celestial bodies packed with precious metals like platinum, gold, and rare earth minerals that are increasingly scarce on Earth. But here's the challenge. Getting those resources back to our planet has always been prohibitively expensive and logistically daunting. That's where space elevators come in. By creating a reliable, cost-effective transportation system, they could bridge the gap between these resource-rich asteroids and our industries here on Earth. Think about it. Asteroid mining isn't just about finding shiny metals. It's about accessing materials that are critical to modern technology. Rare earth elements, for example, are essential for everything from smartphones to renewable energy systems like wind turbines and solar panels. Right now, these resources are limited and often concentrated in unstable regions. But with space elevators, we could tap into a nearly limitless supply, potentially reducing conflicts over resources and driving down costs for critical technologies. And the benefits don't stop there. Imagine the impact on manufacturing. With a steady influx of materials from space, industries could innovate at an unprecedented pace. Electronics could become cheaper and more advanced, energy storage solutions could leap forward, and even space exploration itself could be fueled by resources mined off-world. It's a self-sustaining cycle. Asteroid mining could fund further space infrastructure, which in turn enables more mining and exploration. But how would this actually work? Space elevators would act as the backbone of this new industry, providing a way to transport mined materials from asteroids back to Earth's surface without the massive costs of traditional rocket launches. Instead of burning fuel to fight gravity, mined resources could glide down the elevator's tether, making the process far more efficient. This isn't just science fiction. It's a tangible future that could reshape our economy and our relationship with the cosmos. So what does this mean for us? Beyond the technological and economic implications, asteroid mining powered by space elevators could fundamentally change how we view resource scarcity. Instead of seeing Earth's resources as finite, we could start thinking of our solar system as a vast reservoir of opportunity. It's a vision that challenges us to think bigger, not just about what we need, but about what's possible when we reach beyond our planet. When we think about space elevators, it's easy to focus on their potential for peaceful exploration and scientific discovery. But what happens when we consider their role in defense? The military implications of space elevators are both fascinating and deeply complex. Imagine a world where deploying satellites, surveillance systems, or even defensive weaponry into orbit becomes as routine as launching a drone. Space elevators could make that a reality, offering a faster, more cost-effective way to establish a presence in space. But with that capability comes a host of ethical and geopolitical questions. Who controls these elevators? How do we prevent their misuse? And what happens when space becomes the next frontier for military strategy? One of the most significant advantages of space elevators for defense lies in their ability to quickly deploy critical assets. Satellites, for instance, are the backbone of modern military communication, intelligence gathering, and navigation systems. With a space elevator, launching these satellites could become exponentially faster and more affordable, giving nations a significant strategic edge. Surveillance systems placed in orbit could monitor global activity in real time, providing unprecedented levels of situational awareness. But it doesn't stop there. The same technology that could revolutionize space exploration might also pave the way for placing defensive, or even offensive, weapons in orbit. This potential, however, brings us to a critical crossroads. The militarization of space is a contentious issue, one that has sparked debates among policymakers, scientists, and ethicists for decades. A space elevator could amplify these concerns, as it would make accessing space more accessible than ever. The risk of an arms race in orbit becomes a very real possibility, with nations vying for dominance in a domain that has historically been seen as a shared, peaceful resource. How do we balance the undeniable strategic benefits with the need to preserve space as a neutral zone? Beyond the ethical dilemmas, there are also practical challenges. Ensuring the security of a space elevator would be paramount. These structures would likely become high-value targets, vulnerable to sabotage or attack. Protecting them would require significant resources and international cooperation. And even then, the question remains, who gets to build and control these elevators? The answer could reshape global power dynamics in ways we're only beginning to understand. As we explore the military potential of space elevators, it's clear that the stakes are incredibly high. The technology could redefine how nations defend themselves and project power, but it also forces us to confront difficult questions about the future of space and humanity's role within it. The path forward isn't just about engineering and innovation. It's about responsibility, collaboration, and ensuring that the benefits of this groundbreaking technology are shared equitably. What if the key to protecting our planet lies not just in what we do on Earth, but in how we use the vast potential of space? While space elevators are often discussed in the context of exploration, their impact could extend far beyond reaching the stars. In fact, they might just become one of humanity's most powerful tools in the fight against climate change. One of the most exciting possibilities is their ability to revolutionize energy production. Imagine a future where massive solar power satellites, built in space and positioned to capture sunlight around the clock, beam clean energy back to Earth. These satellites could generate electricity at a scale far beyond what's possible with traditional solar panels on the ground, free from the limitations of weather or nighttime. Space elevators could make this vision a reality by drastically reducing the cost and complexity of transporting the materials needed to construct these satellites. Instead of relying on expensive and resource-intensive rocket launches, we could use elevators to steadily and sustainably move components into orbit, paving the way for a global shift to renewable energy. But the benefits don't stop there. Space debris has become a growing concern, with thousands of defunct satellites and fragments cluttering Earth's orbit. This debris not only poses a threat to active satellites and spacecraft, but also contributes to the pollution of our near-Earth environment. Space elevators could offer a solution by enabling the removal of this debris. Picture a system where specialized cleanup vehicles, launched via the elevator, are deployed to collect and safely dispose of space junk. By clearing our orbital pathways, we could reduce the risk of collisions, protect critical infrastructure like communication and weather satellites, and ensure a cleaner, safer space for future generations. The potential for space elevators to contribute to a sustainable future is immense. They could help us transition to cleaner energy, reduce pollution both on Earth and in space, and create a more resilient infrastructure for humanity's growing needs. And while the challenges of building such a system are significant, the rewards, both for our planet and for the future of space exploration, could be transformative. So the next time you think about climate solutions, don't just look to the ground or the skies above. The answer might just lie in the stars and the elevators that could take us there. Building a space elevator isn't just about dreaming big, it's also about confronting the very real challenges that could make or break this revolutionary idea. Let's start with the basics, the materials. To construct a tether strong enough to stretch from Earth's surface into space, we'd need something far beyond the strength of steel or even most advanced alloys. Carbon nanotubes have been proposed as a potential solution, but here's the catch. We're still years away from manufacturing them at the scale and quality required. Even the tiniest defect in the material could spell disaster, as the entire structure would need to withstand unimaginable tension and stress. And that's just the beginning. Then there's the question of location. Space elevators would need to be anchored near the equator to maximize stability and efficiency, but not every equatorial country has the infrastructure or political stability to support such a project. Imagine the geopolitical tensions that could arise over who gets to build and control this game-changing technology. It's not just about science, it's about power, access, and control. And let's not forget the risk of sabotage. A structure this massive and visible would be a tempting target for those looking to disrupt global systems or make a statement. But the challenges don't stop on Earth. Space itself presents its own set of dangers. Solar flares, micrometeoroids, and orbital debris could all threaten the integrity of the elevator's tether. Even something as unpredictable as space weather could wreak havoc, potentially severing the connection between Earth and space. And what about natural disasters closer to home? Hurricanes, earthquakes, or even a sudden shift in atmospheric conditions could destabilize the entire system. The stakes are astronomically high, and every possible risk has to be accounted for. And yet, despite all these hurdles, the dream of a space elevator persists. The risks are daunting, but so are the rewards. It's a reminder that innovation doesn't come without struggle, and that every giant leap forward requires us to confront the unknown. But these challenges also push us to think bigger, to innovate faster, and to solve problems we might never have considered before. So, while the road to a space elevator is far from smooth, it's a journey that could redefine what's possible for humanity's future in space. Space elevators have been a staple of science fiction for decades, sparking imaginations and fueling dreams of a future where reaching the stars is as simple as stepping into an elevator. One of the most iconic portrayals comes from Arthur C.'s novel The Fountains of Paradise, where he envisioned a towering structure stretching from Earth's surface into orbit. This work wasn't just a flight of fancy, it was grounded in real scientific principles, blending speculative storytelling with a vision that felt tantalizingly possible. This fusion of science and fiction has inspired countless creators, from authors to filmmakers, to explore the concept in their own unique ways. But it's not just books that have brought space elevators to life. In the world of anime, series like have depicted massive orbital elevators as central to their futuristic societies. These towering structures aren't just set pieces, they're symbols of human ambition and technological progress, often serving as for both literal and ideological conflicts. These portrayals have done more than entertain. They've shaped how we think about space elevators, turning them from abstract ideas into vivid, tangible possibilities. And here's the fascinating part. These fictional depictions aren't just entertainment. They've influenced real-world research. Scientists and engineers often cite science fiction as a source of inspiration, using the bold ideas presented in books, movies, and shows to push the boundaries of what's possible. For example, the concept of a tether made from ultra-strong materials like carbon nanotubes, a key element in many fictional space elevators, is now a serious area of study. The line between science fiction and science fact is than you might think, and space elevators are a perfect example of how imagination can drive innovation. So, what does this mean for the future? As we continue to explore the potential of space elevators, we're not just building on decades of scientific research. We're also drawing from a rich tapestry of stories that have captured our collective imagination. These cultural touchstones remind us that the journey to the stars isn't just about technology. It's about the dreams and aspirations that propel us forward. And who knows? The next breakthrough in space elevator research might just come from someone inspired by a scene in a book or a moment in a movie. After all, the future isn't just built by engineers. It's shaped by storytellers too. So, who's actually working to turn the dream of space elevators into reality? While the concept might sound like science fiction, there are real-world efforts to make it happen. One of the earliest and most influential contributors is NASA. Back in the late 1990s, NASA began exploring the idea through its Advanced Concepts Office, funding studies to assess the feasibility of space elevators. These early efforts laid the groundwork for much of the research we see today, proving that the concept isn't just a pipe dream, it's a serious scientific endeavor. But NASA isn't the only player in the game. Across the globe, organizations and researchers are diving into the challenge. Take the Japan Space Elevator Association, for example. This group has been at the forefront of pushing the boundaries of elevator technology, hosting annual conferences and competitions to spark innovation. They're not just talking about it, they're actively working on developing materials and designs that could one day support a functioning space elevator. Their focus on carbon nanotubes, a material stronger than steel yet incredibly lightweight, has been a game changer in the field. Meanwhile, private companies are stepping up to the plate as well. Liftport Group, a US-based startup, has been working on lunar space elevator concepts, aiming to create a system that could transport materials between the Moon and Earth. Their vision: to establish a foothold in space infrastructure that could pave the way for more ambitious projects down the line. And then there's Corporation, a Japanese construction giant, which has publicly announced plans to build a space elevator by the year 2050. Their approach involves leveraging advancements in carbon nanotube technology and robotics to tackle the immense engineering challenges. What's fascinating is how these efforts are converging. From government agencies to private enterprises and academic institutions, the push for space elevators is becoming a collaborative global effort. Researchers are sharing findings, testing prototypes, and refining designs, all with the shared goal of making space travel more accessible and sustainable. It's a reminder that even the most ambitious ideas can gain traction when brilliant minds come together. The advancements in materials science, robotics, and engineering are bringing us closer than ever to turning this vision into reality. And while there's still a long way to go, the progress being made today is laying the foundation for a future where space elevators could revolutionize how we explore the cosmos. The idea of space elevators has long felt like science fiction, but as we stand on the cusp of a new era in technology, it's becoming increasingly clear that this ambitious concept might not be as far off as we once thought. Over the next decade, breakthroughs in materials science, robotics, and energy systems could finally turn this dream into a tangible reality. Picture this: a world where reaching space is as routine as boarding a high-speed train. What would that mean for humanity, and how close are we to making it happen? One of the biggest hurdles has always been finding a material strong enough to withstand the immense forces involved in building a structure that stretches tens of thousands of kilometers into space. Carbon nanotubes have long been the gold standard in this conversation, but recent advancements in graphene and other ultra-lightweight, ultra-strong materials are pushing the boundaries even further. These innovations could provide the backbone for a space elevator cable that's not only durable, but also cost-effective to produce. But it's not just about the materials. Robotics and automation are playing an equally critical role. Imagine robotic climbers, equipped with advanced AI, scaling the elevator cable to transport cargo and passengers. These machines would need to operate flawlessly in the harsh conditions of space, from extreme temperatures to radiation exposure. The good news: we're already seeing glimpses of this technology in action, from autonomous drones to Mars rovers. The next decade could see these systems refined to handle the unique challenges of a space elevator. Energy is another piece of the puzzle. Powering a space elevator requires a system that's both efficient and sustainable. Solar energy is a strong contender, with the potential to harness the sun's rays more effectively as they're unobstructed by Earth's atmosphere at higher altitudes. Wireless energy transmission, using lasers or microwaves, could also play a key role in keeping the climbers moving smoothly along the cable. So what could all this mean for our relationship with space? For starters, the cost of sending materials and people into orbit could plummet, opening up new possibilities for space exploration, satellite deployment, and even space tourism. Imagine a future where scientists, engineers, and everyday adventurers can access space with ease, revolutionizing industries and sparking a new wave of innovation. The road ahead is undoubtedly challenging, but the potential rewards are staggering. As we look to the next decade, the dream of a space elevator is no longer just a flight of fancy. It's a vision that's steadily taking shape, one breakthrough at a time. And if we succeed, it could change not just how we explore space, but how we see our place in the universe. As we marvel at the engineering and scientific breakthroughs that could make space elevators a reality, it's impossible to ignore the deeper questions they raise. Who gets to control a technology as transformative as this? And how do we ensure its benefits are shared fairly across nations and communities? The ethical implications of space elevators are just as complex as the engineering challenges, and they demand our attention just as urgently. Think about it. A space elevator could fundamentally alter how we access space, making it far more affordable and efficient. But if only a handful of powerful nations or corporations control it, the technology risks becoming a tool of inequality rather than progress. The potential for monopolization is real. Imagine a world where only the wealthiest can afford to launch satellites, conduct research, or even travel to space, while others are left behind. That's not the future we should be striving for. On the flip side, there's the question of equity. Could a space elevator become a global public good, accessible to all nations regardless of their economic status? Some argue that international collaboration is the key. A shared ownership model, perhaps under the oversight of a global organization, could ensure that the benefits of this technology are distributed more evenly. But even then, challenges arise. How do you balance competing interests? Who gets priority access? And how do you prevent powerful entities from dominating the decision-making process? Then there's the issue of environmental and social responsibility. Building a space elevator is no small feat, and the resources required, both financial and material, are immense. Who bears the cost? And how do we ensure that the communities affected by its construction, whether on Earth or in space, are treated fairly? These aren't just hypothetical questions. They're real concerns that need to be addressed before we can fully embrace the promise of space elevators. What's clear is that the ethical considerations surrounding this technology are as vast as the cosmos itself. The decisions we make today will shape not just the future of space exploration, but the future of humanity's relationship with the stars. It's a conversation we can't afford to ignore. Picture a world where countries and corporations aren't just racing to explore space, but are competing to control the very infrastructure that makes space travel affordable and accessible. That's the potential reality with space elevators. These towering structures could revolutionize how we access space, but they might also ignite a new kind of space race, one fueled by economic ambition and geopolitical tensions. At its core, a space elevator would drastically reduce the cost of sending payloads into orbit. Instead of relying on expensive rockets, which can cost thousands or even millions of dollars per kilogram, a space elevator could make space travel as routine as shipping goods across the ocean. This opens the door for industries like asteroid mining, satellite manufacturing, and even space tourism to flourish. But with such immense economic potential, the question arises: who gets to build and control these elevators? Nations with the resources and technological expertise, like the United States, China, or Japan, might see this as an opportunity to assert dominance in a new frontier. Meanwhile, private companies like SpaceX or Blue Origin could push to privatize the technology, creating a competitive market, but also raising concerns about monopolization. The stakes are high, and the race to build the first operational space elevator could mirror the Cold War-era space race. Only this time, the prize isn't just prestige, but trillions of dollars in economic value. But with great opportunity comes great risk. The competition could lead to tensions over who controls key orbital slots or the resources needed to build and maintain these elevators. For example, the carbon nanotubes or other advanced materials required for the Tether are rare and expensive, potentially sparking disputes over access. Add to that the geopolitical implications of controlling a structure that could serve as a gateway to space, and you have a recipe for both innovation and conflict. What's fascinating is how this dynamic could reshape global alliances. Smaller nations might band together to pool resources, while larger powers could engage in strategic partnerships or rivalries. And let's not forget the role of international organizations. Will there be a new set of treaties to govern space elevators, much like the Outer Space Treaty of the 1960s? Or will the lack of clear regulations lead to a free-for-all, where the strongest players dominate? The economic ripple effects don't stop there. A thriving space elevator industry could create millions of jobs, from engineers and technicians to logistics specialists and even space-based construction workers. It could also spur advancements in related fields like robotics, materials science, and renewable energy. But as with any major technological shift, there's also the risk of economic disruption. Industries reliant on traditional space travel might struggle to adapt, and the concentration of wealth and power in the hands of a few could exacerbate global inequality. So, while space elevators promise to democratize access to space, they also raise complex questions about who benefits and who gets left behind. Will this new frontier bring nations together in collaboration, or will it deepen existing divides? The answers could shape not just the future of space exploration, but the future of our global economy as well. And as we stand on the brink of this transformative era, one thing is clear. The race to build the first space elevator isn't just about technology. It's about power, prosperity, and the very nature of competition in the 21st century. Space elevators aren't just a futuristic dream. They're a vision of what humanity can achieve when we dare to think big. Imagine a world where reaching space is as routine as boarding a plane, where the vastness of the cosmos becomes a second home for exploration, innovation, and even everyday life. This is the promise of space elevators. They could revolutionize how we approach space travel, turning it from an exclusive, high-cost endeavor into something accessible to everyone. The benefits are staggering. By drastically reducing the cost of sending materials and people into orbit, space elevators could open the door to entirely new industries. Think about it: mining asteroids for precious metals, constructing massive solar arrays in orbit to power entire cities, or even building habitats on the Moon or Mars. These aren't just science fiction fantasies. They're real possibilities that space elevators could make economically feasible. But it's not just about the practicalities. Space elevators represent something deeper, a symbol of human ingenuity and our unyielding desire to explore the unknown. They remind us that the challenges we face today, no matter how daunting, can be overcome with creativity, collaboration, and determination. Yes, there are hurdles to clear: materials science, engineering, and international cooperation, to name a few. Yet, the potential rewards are worth the effort. As we stand on the brink of this new era, it's worth reflecting on how far we've come. From the first satellites to the International Space Station, humanity has already achieved incredible feats in space. Space elevators could be the next giant leap, transforming how we interact with the universe around us. They could make the stars not just a distant dream, but a reachable destination. Thank you for joining us on this journey through the possibilities of space elevators. If you found this exploration as exciting as we did, don't forget to like, share, and subscribe for more deep dives into the future of technology. The cosmos is waiting. Let's see where we can go together.